Hey team, so today we're working on factoring the difference of squares. This one takes a little bit of noticing, so you have to notice that they're squares. So in general, you'll see that this is a perfect square number. This is x squared, or maybe x to the fourth, some kind of square variable. And then this is also a square. So the numbers that I'm talking about with squares are like 1 times 1, so 1 is a square. Or 2 times 2, 4 is a square. Or 3 times 3, 9 is a square. So these are all considered square numbers. So the other ones are like 16, 25, you can think of them, 36, 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and so on and so forth. So the idea is this. We would take each of them, we're going to split them up. So we would take this number and split it here and there. We would take this number, and we're going to split it here and here. We're going to take this number here, see? We're going to split it and make this number and this number. And then we have positive and negative. It must be subtraction. If it's not subtraction, then we can't do it. And the reason is because a positive and a negative make a negative. And so it must be subtraction. So if we look, for example, we're going to look at this problem here. So this is our problem, 81x squared minus 36. So the first thing we're going to check is there a GCF? So in this case, there's nothing that I can divide out of those two. Oh, actually, I can divide 9 out. So I can take 9 out like this. So I would have 9x squared minus 4. I have that 9 on the outside there. From there, I can see that 9 is a square, x squared is a square, and 4 is a square. So I'm able to split this up. So I have two terms that are squares, 9x squared and 4, and it is subtraction, so I can do it. So 9x squared becomes 3 and 3, x and x, because 3x times 3x would give us that 9x squared. And then 4 becomes 2 and 2, because 2 times 2 would give me 4. And then I'm going to have one positive and one negative term. So I think this is my answer. I'm going to go ahead and double check by using the box. So I have 3x plus 2 and 3x minus 2. So I'd have 9x squared, 6x, negative 6x, and negative 4. I can see that these ones cancel. That will always happen with the difference of squares. And I can see that I would have 9x squared minus 4 left over. So I can see that that is there. And then the 9 multiplied times 9 will get me back to my answer. So I know that this section here is the correct answer. Right? So I'll do a few more examples here. So first example, b to the fourth power minus 16. So b to the fourth power is like b squared times b squared. So that means that I can put that here, b squared times b squared. And 16 is like 4 and 4. So I'm going to put 4 here and 4 there. I have one positive and one negative. Right, so this is kind of like a shortcut for the x factor. For this next one, I'm going to check for a GCF. I see that they both can be divided by 2. So I have this here. 2 is going out in front. Left over x squared minus 8 divided by 2 is 4. I can see that x squared is a square and 4 is a square. So I know that I can do the difference of squares. Leave my 2 there. 2 parentheses. X squared turns into x and x. 4 turns into 2 and 2. One positive, one negative. This is my factored form of that equation, expression. I'll look at number 3. Number 3, I have a square here. 4x would be 2x times 2x, and 25 would be 5 times 5. So I can see those are two squares, 2x times 2x, 5 times 5, positive and negative. So this is my factored form of this. And then finally, this one, sometimes it can be really tricky when we have a -1, easy to forget, but that is a square, that's 1 times 1. 9x squared is 3x times 3x, so I would have 3x minus 1, 3x plus 1, and that is it. You have a few more practice ones here. Go ahead and try and practice them on your own so that you can figure it out. Thanks, guys.